Hello everyone, I am Kathiriya and our topic is the implementation of the Chord algorithm. We have explained this algorithm in detail in another video and provided the link to that video in the document. In this video, we will give a demo of our code. To do that, let me explain the .h files used in our project. This is port.h file defines a class called socket and port, which is used in our project for handling network sockets and port numbers. These are the class members. Port number of server. This integer variable stores the current port number being used for the server. This integer variable stores the socket file descriptor and the current stores the current socket address. These are the member functions which we will discuss one by one. Specify port IP to server. This function sets up the server socket and binds it to a port number. Change port number. Function changes the port number the server uses. Close the socket. Function closes the socket and frees up any associated resources. This function checks whether port number is already used on the specified IP address or not. This function returns the IP address associated with current socket. This function returns the current port number used by the server. Similarly, this last function also returns the file descriptor for the existing socket. Node-information.h file is a header file for a class called node-information, which is used in distributed hash table implementation based on Chord protocol. The class contains variables and methods necessary for Chord protocol operations and key value storage and retrieval. The variable includes the node ID, information about the predecessor and successor nodes, finger table information about other nodes, a dictionary to store key value pairs, a successor list, and a flag indicating whether the current node is part of the ring or not. The method include Chord protocol operations such as finding the successor and the closest preceding node ID for a given node ID, updating finger tables, performing the stabilize operation to update the node's successor and notifying the successor of the node's existence. It also includes method for key value storage and retrieval and setting and getting node information. Now let's understand function.h file. This code defines a header file that contains function prototypes for operations in a distributed hash table using the Chord protocol. The functions include storing and retrieving key value pairs, creating and joining a ring, printing the state of the node, listening for incoming connections from other nodes, performing stabilization operations, notifying the successor node, leaving the ring, and displaying help. The functions use the node information class, which contains information about the current node in distributed hash table. Now let's understand help class.h file. This code defines a class helper functions that contains various helper functions for the distributed hash table implementation. This function include splitting a command into separate words, combining IP address and port number into a single string, generating hash values, checking if a node is alive, setting server details and timer, sending and receiving data to or from nodes, and getting the predecessor and successor nodes. These functions are used to implement the core functionality of distributed hash table, including storing and retrieving key value pairs, creating and joining a ring, and maintaining the state of the nodes in the network. Init.h file defines the function prototype for split command and initialize. Split command takes in a command as a string and splits it into separate words, which it returns as a vector. Initialize is a function that initializes the distributed hash table and sets up the network for the distributed hash table system.
Now we will see a live demo of our Chord protocol. To running a node on a device, we simply need to build a makefile. As you can see that the current node is running on device IP address 10.0.2.15 on a port number of 4 times 5. Now we simply have to we have command help that we can show that we have all command that we can use in our code. First one is the create, which we'll use to create a code ring. Second command is join IP address and port. From this we can join the ring by connecting to node having IP address and port given. And third one is the print state. It will print the successor, predecessor, finger table info and successor list. The fourth command will be print. That will print all keys and value present in current node. The fifth one is port, will display the port number on which node is listening. Sixth one is the put key value, will put key and value to the node it belongs to. Seventh one is to get key and eighth to leave the node. From the first node, we simply create a code ring. After the create command, we can see that the ring is created with the current node's IP address and port number. Print state command will give us the finger tables and the self node, successor node of current node and the preceding nodes of current node. After that, we will run our second node as similar as the we run the first node. Like we build the make file and the node will start it. The second node will have on its device IP address 10.0.2.20 and port number 8967. To join the code ring which we have created with the first node, we use simple command join IP address of the first node, which is the 10.0.2.15 and the port number 555. After that, we can use the print state command. Print state command will basically print the self node. We have the self node and successor node and precedent node. Successor currently we have a two node in our system. The successor node, the node which have created the ring, and the second node. So the successor and precedent of the second node will be the first node, as we can mention here the IP address of first node and the port number of that, and from it will make the finger table and the successor list. So like first successor from the current node will be the our first node, then the second node, and so on.
Now we will run third node on different virtual machine. We can start the node. The third node is currently on IP address 10.0.2.25 and the port number 4987. We can join the third node with command join. IP address of the node that created on the chord ring, which is our first node 10.0.2.15 and the port number of that is 5555. After that, the print state command, which is basically printing the finger tables. Here self node, successor node, predecessor node finger and the successor node leave. After that, we can put the value on the chord ring with the put command. Basic put command with the put then key value. Put Ronit third node and then put 520 x5 x5 and we will get the data through the get command. It is simply get and the key. If key is not available in our chord ring, then it shows key is not found. Basically, this hash is the key value hash, and then after the print command will print the data available at current node. From current node, we know that data will be stored on hash successor node of the key value hashing. In our case, third node currently doesn't have any data. Now in the second node, we can get the third node value from the key like get Ronit, get 500, and we can also put the value at the second node like put Harsh, second node, put 100 10x10, and print command will print the data available at the second node, which is currently having the second node and third node.
Now we come to our first node. Due to stabilization procedure, it will change its finger table. Like its first node is a self node, second node is a successor node, and third node is a predecessor node. Now we take the second node from get Harsh function. Now we will get Ronit it is our third node. Now we will check that the data of third node that we have entered with the node 500 square at the rate level with the first node, and the finger table state of the second node will be changed as we run two thread to all the node. Our first thread will be stabilizing the protocol, means that specifies all the nodes that its finger table is uploaded and all the successor table and finger tables are to the mark and updated till the work is done. Now we can see that our successor list and finger table both are changed. This is basically due to the stabilization protocol run behind the process, and the other purpose is form the listing from the other connections.
Now we will see the leave command. The leave command is used to remove a node from code ring. So after running the leave command for the third node, when we see the finger table through the print state function, we observe that the third node is eliminated. If we run the leave command for the second node, now after using the print state, we see the updated finger tables. Hence we can say that the protocol is running perfectly all right. Thank you.